Okay, so the next problem that we have is the multiplication of complex numbers. I did addition in the previous video. So in this problem we have z1 is equal to 1 plus 2i, and z2 is equal to 3 minus 4i. So the same numbers we had in the addition problem, but we're going to multiply them across here. So z, we're just going to call it z, is equal to z1 times, oh, my camera broke loose, hang on a sec. There we go. Sorry about that. z1 times z2 is equal to 1 plus 2i times 3 minus 4i. And the way to perform this is really just FOIL's method. So first outside, inside, last. And if you go ahead and do that, right here, right here, and right here, and right here, you end up with 4 minus 2i. Oh, sorry. That's not right. I'm looking at the wrong part of the wrong problem. I'm looking back at my addition notes. You end up with 11 plus 2i. Okay, so fairly easy right there, not too difficult. Let me double check that here real quick. So you end up with 3 plus, let's say 3 minus 4i, and then 6i plus 6i minus, and then I times I is also a minus, so you've got minus 8 plus 11 minus 2 plus 2i. Okay, yes, that's correct. Thought for a moment there was a mistake somewhere in the notes. Alrighty, but now we want this in the form of Euler's I theta. So again, since we have this, you just go ahead and use Pythagoras' theorem and figure out the sides of the triangle that I explained in the addition video. So the amplitude is equal to square root of 11 squared plus 2 squared, which is then equal to 11.18. And then theta is equal to tangent, inverse tangent, or arctangent, 2 over 11. It's equal to 0.18 radians. In vibrations, we'll always work in radians. So those are your two coefficients. So then z in Euler's form is equal to 11.18 EI 0.18. And that's your final answer. Both of these are legitimate and equal, so it depends on how your instructor wants it, if he wants it in imaginary form or if they want it in numerical form. So that's a preference based on your professor of how far you have to take this. Usually you have to take it all the way into Euler's form.